Hi everyone, this is Mehul Mehta and welcome back to my YouTube channel. Today we have a very special guest. He is Somdeep Datta. Just to give a brief about Somdeep, he has 20 years of working experience as a quant and his longest period was 10 years at Goldman Sachs. So I'm very sure that in today's podcast we'll learn a lot from him. So if you're someone who's new to this field or you are someone who has started in this field, I'll say like take a notebook so that you can take notes because I'm very sure that we have a lot of things to learn from Sandeep. So Sandeep, before diving deep into this, first of all, I really want to thank you. And like, can you walk us through your education background and can you tell us your story about how you ended up becoming a quant?
Sure. So the short version is that I'm engineer by education, adopted finance as a profession, and I'm a comic book writer on Fridays. The long version, well, I went to IIT Kharagpur. I did my bachelor's in technology in electrical engineering, or rather, electronics and electrical communication engineering over there. Then I went to Princeton. I completed a PhD program also in electrical engineering, learned a whole bunch of mathematical skills there, which became really useful later in finance. So in 2004, well, when I finished my PhD, it turned out optical networks, which was my specialization, was not so hard at that time. So I spent 13 years in Goldman Sachs in convertible bonds desk, in CVA and FVA with structured products desk, and also in the clearing division. And then I spent another 6 years in a fintech company working with multiple clients in insurance, regional banks, commodities. And
Wow,
finally,
that's
I'm independent now and I'm working on my own product.
Oh, okay. Yeah, okay, definitely. Can you tell us more about because I know like the kind of product you are building. So we'll be talking that in the end because I believe your product will be a great service to all the quant aspirants and like of course to the quant community. But I just wanted to ask more on because you said like you worked for almost 13 years at Goldman Sachs, and I feel like Goldman Sachs is like of course everyone's dream. So like like what kind of work you were working on? Were you working on developing models or was it calibrating models or is it model validation or like what kind of projects you were working on if you can tell more about it.
Sure. So let me pick like my first 5 years was with the convertible bonds desk, right? And that in that period, Goldman was progressively automating things more and more. The work really involved everything. You first start with a model. There are a bunch of models in the literature, but then you have to implement them. Oh, well, before that, you have to pick which model you want, implement them, validate them. Then in the process of using it, you might find stability issues. So you have to work on convergence, reducing noise. There are performance issues. So you have to make them faster for your risk systems. Then you need to figure out where the inputs are going to be coming from. Some inputs are clear. Stock price comes from the exchange. But when you get into wall surface, dividend projections, credit spreads, things become more and more murkier. Sometimes you have to be creative about sourcing that and figure out different ways of calibrating it. And then you have to design quoting tools, risk dashboards. One of the fun things I did towards the end was to work in creating a convertible bond index with market partners. And so you can see like it covers the whole range of different things.
So what I understood is you worked on fixed income, you worked on derivatives, you worked on risk side, and of course everything include modeling. So you were building like different models. So can you tell us like what kind of models are being used in the industry? Like in academia, if you see, we have been taught Black-Scholes model, binomial prime model. We are on the volatility side, like Heston model, local volatility models, and then different like we are taught so many bunch of models. So I really wanted to ask, like, have you ever used all these models in the industry while you were working on any asset pricing, or were you using, or if you can tell us like what kind of models you were working on?
Right. Uh, so yeah, in the academia, of course, there are lots and lots of different kinds of different models. People are throwing out Now, industry tends to be a little bit more cautious, works with a fewer set of models because to use any model, there is a lot of work you have to do. You have to have a reasonable, feasible calibration procedure, and you also need to have the code to price all the different products that you're trading on. So, well, Black-Scholes is of course used for quoting everywhere. Local volatility is kind of bread and butter. You're supposed to have at least some implementation of that as benchmark at least. And then, yeah, Heston, Hull White, you will usually have some variants of that. Then, depending upon the specific problem, you might need hybrid models, ones that use both rates and equities. Uh, Depending upon the product, also, it might sometimes Monte Carlo models are better, sometimes PDE models are better. So, you'll have a suite of both.
And just for the viewers, PDE is partial differential equation. So, so because there are a lot of students who who might not know these terms. So just for clarification, also like because a lot of newcomers they want to come into the field of quant finance. So what do you think are like are the important skill set when I speak about statistics, mathematics, programming, and like how much in depth someone should know when he's joining as a fresher? So if you can, tell
Right.
more about it, yeah.
So some things actually haven't changed a lot since I interviewed 20 years ago. They asked three kinds of questions: uh, programming, mathematics, and puzzle solving. And the last one is really important because one of the important skills is not just to know how to solve the math, but how to figure out what math to solve. Given a real world problem, how you transfer it into a certain math. So starting with a puzzle and figuring it out what to do is really important. But other things have changed. Like when I interviewed, you were not expected to necessarily know a lot of financial engineering because all these MFE programs were not there. So you got people who knew math from physics, engineering, and trained in finance. These days, I think they do expect you to know some more of financial engineering.
Definitely, I guess, and right now, like when I talk to so many students, they say like our interview was left, right, center on derivatives, fixed income modeling, all this Monte Carlo, different Monte Carlo. I mean, like how to use Monte Carlo for asset pricing, Greeks calculation. So I believe like right now it has become really rigorous, and like they really want to understand from the modeling perspective, like how have you built the model, what assumptions have you taken, how to deal with the assumptions and stuff like that. So
Yep.
yeah.
Yeah, I mean, you will find that big firms like, say, Goldman Sachs might still take in people who are just bringing in math because they have the patience to train you on the job. Smaller funds or hedge funds would probably want you like, ready to go with everything you know.
Definitely. Also, can you tell like how much programming is required? Because there's a lot of confusion around this area. So I was talking to a junior and he said, I think we should know competitive programming for quant finance. And I was like, why do you need competitive programming? It's only needed if you want to become a quant developer. But then if you can talk about little bit about that, so like that would be interesting to hear from you.
Well, programming is definitely needed because, from writing the model, like I said before, in every piece, you need almost everything you're doing in programs, right? But having said that, you don't necessarily need to know a particular programming language. So you could generally expect that if you know one, and then depending upon the form's needs, you will probably pick up whatever the need over there.
Right. But do you think, like, can you tell, like, which programming, if someone is starting fresh in this field, like, which programming language should he start from, and like, how much in depth someone should go into the programming world?
So, well, I think Python is an obvious choice because everybody is doing writing examples and things there. And one of the things, Python could be slow with certain things like loops, but then knowing how to use NumPy or SciPy well goes a long way in writing very efficient programs there too. Mm.
Right. Also, on the mathematics and like statistics side, like, can you tell because some like because stochastic calculus, not everyone knows and not everyone, enjoys also. Like, not lot of people enjoy working on stochastic modeling and I mean stochastic calculus as such. But like, can you tell us like how much mathematics is actually required in the quant role, like as of yours, and how much statistics is required in these kind of roles?
Right. So I am more from a derivatives background, so their statistics is relatively less, and it's more uh, calculus, either stochastic or otherwise, numerical techniques and algorithms too. So now you may not be actually writing a model all the time because frankly, 95% of the work is like taking a model and then working on different aspects. And so yeah, depending upon, you might need some understanding, but I think it is okay that if you are not a pro in stochastic calculus, but at least you know calculus or have some qualitative idea about how things work.
And on the statistics side, is it like because of course like I learned statistics back in engineering, but in very detail I learned during my master's journey. So there was this whole semester long class on statistics, and we were taught like rigorous statistics. So like, and that's why I realized, okay, statistics is also an important integral part of quant finance. So like, what do you think on like on the world of statistics? Like, how much is it needed, or like, is it I mean, so when any views on that?
Yeah, I mean, it's definitely needed. Like, I think my comment was more about my specific role. But then folks who are trying to take relative value trading or back testing and coming up with trading strategies, yeah, you need a lot of statistics. And in particular, like familiarity brings intuition. So, like, not just knowing the definitions and derivations, but you just see something and you understand what it means. Right? Just staring at results and making sense of it. That kind of skill.
Definitely. Also because you were in the hiring panel, also you were in the hiring, you were also a hiring manager. So a lot of students, they are just confused, what kind of resume they should have, or let's say what kind of projects they should have in their resume, or what I mean, if you can tell us like what do you think are, important projects like that someone can work on, and like anything if you can tell, like, so that because when I started my journey, I was, all over the place. There are so much suggestions over the net. Do this, do that, do this, do that. And I was so confused when I just started my journey. So it's always good to hear from, someone who have been this. I mean, of course, people like you have been in the industry for a long time. So
Right. So I can tell about two things. One is, let's say you do a project and you have your code or slides or a paper or something. So one thing that is, if someone is looking at that, so one thing that is important is how you present it. Because I would want to see that how well you have described the thing, how well you have done your plots. It actually tells a story. The other part is, okay, someone is looking at your resume and you are sitting in an interview and they are looking at what projects you have done. So here I would think a long list is not important because what the interviewer is going to do, he's going to pick on one and then he's going to ask you more in depth on that, right? So you want to make sure that if you have put something on your resume, you are able to show that you actually know what you're talking about, So as an interviewer, I would like that you mention a project which you probably just spent a week, and the moment I ask some non-trivial question, you don't know what I'm talking about, right? So yeah, so put something that you can actually talk about and you can again tell the story about. So in fact, sometimes
yeah.
when I interview um, about a certain project, I myself may not be an expert on that area, so I may not know the technicalities, but I'm looking to see if you can explain me, you can tell me the story about what you did.
Understood. But any like I mean any suggestions for students like like kind of projects, because there's not much clarity on like, what projects to put on resume. So if you can give a little clarity on that, yeah.
So the in in derivatives particularly, there are several aspects, right? One is different kinds of models. So I think I mentioned before, if you're familiar with both Monte Carlo and PDE, partial differential equation models, so that shows that you have diversity. In terms of uh, in terms of the pipeline, even with a model, you got calibration, and then you got just pricing different products and just knowing how it works for different products. And lastly, understanding risk, that how does rate risk work for this product versus that product? How does it qualitatively differ, like, rate risk or volatility risk for different kind of things? So that kind of gives you the breadth of things that you can work on. But again, you don't have to do everything. Like, just make sure what you do is you do it well.
Understood. Also, like you were telling, I mean, I just wanted to understand. Can you tell us a real project that you have worked on at Goldman or at any other organization? And can you tell like what's the overall process of starting from getting the data, building the model, and maybe fine tuning
Right.
it? Or can you talk about like what any of the models you were working on?
Okay. So, well, I said a little bit about convertibles, but let me tell you about another one, CVA. That is where I spent about 4 or 5 years. So CVA is counterparty valuation adjustment. That means you got a derivative contract with somebody else. The contract has certain market risks because of stocks or rates moving, but there is an additional risk because your counterparty might default. Time to pay, your contract is worth something, and counterparty says, no, I'm bust. And so CVA is all about, now you got an additional risk factor. Counterparty is credit. And then you have additional constraints. There might be a collateral. There might be multiple contracts with the same counterparty, all with the same collateral. There might be a correlation between counterparty's risk and the market factors. So as you add on, you find that this this modeling can really get very intractable because there are so many moving parts. So when we started doing that, and the trigger was, of course, the 2007, 2008, everything becoming much riskier and borrowing rates going up. So we found that different desks ended up prioritizing different factors. Some said, "Oh, for us, for our deals, correlation is not important, so drop that." And somebody else said, "Oh, for our deals, um, you don't have to have portfolio effect. You can do each deal independently. So let's do that." So it was a combination of picking what is important and then going and writing a whole new set of models, which so far textbooks did not really cover well. Right.
So, like, how did you come up for the model? Was it like basically by reading the research papers? Because I understand that, like there were a lot of moving parts. As you said, like correlation is one risk measure, and like that there may be multiple risk measures that you might be looking at. So, like, how did you build the model? Like, if you can talk about like the building processes.
Right. So we did look at a lot of research papers and ended up taking various approaches. So for one set of deals, for example, we found that American Monte Carlo served our purpose. The Monte Carlo, because when you're dealing with a portfolio with a lot of products, and on top of that, the counterparty credit and funding, now you've got a lot of factors. When you have a lot of factors, PD models don't work very well. You need Monte Carlo. But then you might have early exercises. When you have early exercise decisions to make, a regular Monte Carlo doesn't work. So you need American Monte Carlo. So that was what was driving the choice of the model. And then you have to calibrate a bunch of things. You have to mark a bunch of things.
Okay. I'm just curious, like, how did you build like the calibration stage? Like, how did you, let's say, because I believe like someday, like, because I've been also working on multiple models, and I believe like we have to calibrate our model with the market data. So like what kind of more like how are you calibrating the models? And if you can talk about that and yeah.
Yeah, so you basically pick uh, when you have a bunch of parameters, certain parameters you will probably just mark based on intuition. Some parameters you might do a back testing with a lot of historical data, you will calibrate certain things and you won't change it day to day. And a certain set of parameters you will probably calibrate on the fly, right? Of all, I would say my favorite is the trader calibration.
Say what
The way
trigger
trader,
calculation?
fader calibration.
Trader.
So this is how it
Okay.
works. The trader who is in charge of the deal, he comes and you're sitting there and you discuss, okay, so we got this particular alpha, which we don't know how to mark. And so the trader asks, oh, what if alpha is 50%? What's the value of the deal? I will say, it is 8 million. And the trader says, how do you get 10 million? So then I'll calculate and say, oh, then alpha has got to be 32%. Yes, 32% it is.
Oh, really? So is it kind of
Well,
negotiation or
well,
is
it
it?
depends. Like, it's not like he's uh, shooting from nowhere. The reason why he says 10 million is maybe it's not a liquid market, but there are inter-dealer deals. So he has a sense where that deal is going to be sold. Right. So it's,
Okay. So based on like, so you like you knew like what the outcome will be from the trader, and then you were going in the backstage, basically going in the backward direction. Is it what is that the case?
yeah. So it is, you could say it is calibration only, right? So that
Yeah.
it's not a mark or a price of the exchange, but something that the trader has some sense,
Oh, okay.
right?
Yeah. Oh, that's really exciting to know because what I have worked on mostly is like using my maximum likelihood estimator or least square estimator to calibrate my model with the market data. So kind of interesting to get the sense of how to calibrate the model. Is were there any other techniques were you using for like I understand you did mention about other, but were there any other stuff that you were using for calibrating the model?
Um, so I think you always have this three categories, right? A few which just doesn't change. You have a sense, and a
Right.
few you calibrate um, maybe once a month, and a
Right.
few you calibrate more frequently so that you match whatever is liquid market data is coming in.
Mhm.
And so that is basically the general framework, because you can't, if you have like 20 variables, you can't have a stable result if you try to calibrate everything.
Right. No, I agree definitely. So yeah, definitely. So after you calibrate the model, then after that, like, what's the next stage? Is it like, okay, so you use the model for pricing assets, or like, or does the model needs to go to the validation team so that they can validate the model and then you can use it, or like, what's the
Yeah,
process there?
so depending upon the firm, well, Goldman Sachs definitely had multiple groups. Front office would write a model. Um, there is a independent validation group which would make sure that they have their own views, tested it with
Mhm.
their inputs, and they will give their blessing to.
Okay,
And yeah, and
really
then you can
fun.
use it. So there was a whole regulated framework about this, what model you can use and when you can use.
Is there any regulatory document on like how like I know like SR 11.7, SR 15.18 on how to like these are used by a lot by the risk like model validation team to like basically come up like how to validate the model. But is there something on the derivative space like regulators have come up for the modeling piece? Is there any document like that?
I'm not sure what document to point to,
Okay.
but definitely there is definitely a process that you have to put in, which would involve a bunch of back tests and writing down everything that you did.
Also, like I was just curious, can you use the model? Let's say there was a in-house model that you developed. Can you use the model for pricing the asset without taking like the permit, without validating the model from the risk team, or every model used to get validated from the risk team and then only it was used?
Every model had to get validated,
Oh,
right?
okay, understood.
Yeah,
Hmm. Okay, this is exciting learning because sometimes if people say, "Oh, we developed this model in house and we are using it," but I always thought, but they send because validation team also takes like a rough, 2 months of a month or two, and then you can use the
right.
model. So
I think,
yeah,
well, all larger banks and institutions would have a very specific process to make sure you can't just, pick any model. There would be some kind of
definitely.
independence too between the team that writes the model and the team that validates it.
Mhm. Perfect. Yeah, definitely. So this was all about, about your working experience. Now I want to understand like the package that you are building for the quant community. I believe it is called Tablet, tablet with, I mean, cube with the
Yep.
tablets with Scablet. So can you tell us more about it? Like, what was your motivation and what kind of, what is it actually? If you can walk us through.
Sure. So let's say that Quant comes up with a new model, right? You do some math and then you do some validation with vanilla prices. You work out good calibration techniques, and you do some studies about how does the implied volatility look like, and this and that. And we see lots and lots of such papers about many different models that has been published over last 15, 20 years. What I see is that the buck stops when it's time to take that model and actually use it. Because then you find that, oh, I got a portfolio of 20 different contracts with different payoffs. Now I need to take that model and have an implementation that can price product one, product two, product three. And for each of them, I need to write a whole bunch of code. And so that is where Cablet helps. Now, the underlying theory has been known for a while that almost any financial contract can be described using a series of payments, certain choices, and certain conditions. You know? So you could describe your contract using these primitives. Now, to actually write a model that can price any combination which has been described a certain way, certain implementations have been closely held only by a few large players. So what
Yeah.
Cablet does is it offers a version which is easily accessible, easy to visualize, and and a very simple interface. So what
Okay.
this makes it possible that a quant writes a new model and wants to price autocallables, cliquets, barriers, then you don't really have to go write a lot of custom code for that.
Oh, so it's already basically it's a package which we can use to directly go and price and basically add some functionality to it, like let's say jump to default or any other conditions, whatever it is. So is it something like that?
It's like, let's say you wrote a jump to default model, right? And so you write it in Cablet's interface, and now you can price an autocallable, or you can price a commodity contract. You can price a whole range of contracts without having to go back and re-implement your model.
Oh, okay. So someone who's starting fresh don't need to write the model from scratch. Basically, someone can utilize Scablet to basically price different derivatives or any other instrument which has been traded in the market. Is my understanding right?
Right, essentially, yes. And yeah, we do have extensive documentation, a series of notebooks in order to walk you through and how does that work.
Motivated you? Because I believe there'll be a strong motivation because there are so many financial products in the market which are being traded. So I'm very sure that there'll be so many models, and with so many models, there'll be different functionalities attached to it. So like I'm very sure that you're first of all you're very passionate about building the models and adding different functionalities. So what motivated you to build this whole package?
I think I kind of faced this issue like firsthand, that people coming to us, that was specifically in my last job, people coming us and asking about different contracts that, hey, our contract has this feature or that feature. Can you tweak the model? And I found that that was very difficult to do unless you have such a framework.
Because every
And
time you tweak it, do we also need to take permission from the validation team to use it?
uh, well, actually, in this case, normally the validation will be two parts, right? One is for the model. So in
Yes.
this case, you don't have to go and revalidate the model.
Okay.
But of course, like in order to create a new product, you usually need some validation for the product itself. So you will still need that.
Oh, okay. I mean, can you give us like one more example of like how to use your, because I'm very excited to use the package. So can you give one more example of any model that you have in the package and like what other functionalities can be added to the model? So if you can tell us about it.
Sure. So for example, one of the things I was recently working on is uh, there is a class of models called Bergomi models, and rough Bergomi models, and there has been a lot of research on their behavior, how it fits the wall surface. However, there has been very little work in actually using it and pricing a clique or an autocallable, right? Because then you have to go and change all that. So I have started putting together some notebook, and actually I'm working on um, having a group of volunteers who can take many of the recent models that have been developed and see if they can price a range of the typical exotics like autocallables, barriers, and cliques.
Okay, yeah, that would be great. I am sure, like after hearing this podcast, a lot of students and professionals might reach out to you, and I hope some organization might reach out to you for your package. So one last question which I have for this podcast is like any advice which you want to give to the quant aspirants, because there are a lot of students who want to enter into the space of quant finance. Back in, I know like in India, there's a lot of, I mean, things are not that clear as it's in United States, because there are so many master's degree in US, so things are pretty clear here. But things in India is pretty, like it's not that clear. And of course, other countries like Bangladesh, Pakistan, China. So any advice or anything which you want to suggest to students who want to enter into the field of quant finance?
One advice I will give is that as you write and try out different models or do some math using notebooks, I would say try to develop an intuition behind what is happening. So, like you wrote some piece of code and you price something and you are looking at a plot or a table of numbers. So just stare at it, just see how it makes sense. Get the big picture. So
Mm.
if you have a stronger intuition, well, one is intuition and the other is connection between different models or different pieces of math. You will see that if you see the connection, the whole math becomes a lot easier.
Definitely, no, that's a great advice, because understanding the model is important, and what's coming out of the model is also equally important. So definitely that's a great advice. So one last question that actually I thought of asking you after hearing this is, so we have bunch of models, like Black-Scholes binomial and all bunch of different like Monte Carlo method. We have PDs and stuff like that. PDs again Black-Scholes. So my question to you is, of course, if we are pricing any asset, and so of course it will not match 100% with the price of what's the asset that is being traded in the market. So how do cons go about that? So do they just use the model just to understand, have a basic understanding of, okay, this is the price, like if you can talk about it, like I understand because different models, they come up with different prices. So how do you know like which one to select or something like that?
And if there is a liquid price for the thing that you're trading, for example, vanilla option prices, then you would definitely want your models to fit that, right? And which is one of the reason why even though Heston model with 5 parameters or rough Burgomi with say 4 parameters explain most of the surface, but you can't really start using it unless it fits all the surface to some within certain error margin. So you want to fit everything that is observable. And then the things that are less observable, you have some latitude to have your judgment about, which model to use. So that is one. And the second is you are not just using the model to just come up with a price or just to predict a price. You're also using it to uh, get risk. So you calibrate to the current price and then you move around all the inputs to see what your risk might be. You are also using it for explaining your P&L. You know yesterday's price, you know today's price, but you're trying to figure out which factors led to, which movement.
Okay, understood. Yeah, this gives me a complete picture of, of like, of course, building model is one thing, utilizing model is one thing, intuition is all, of course, another, I mean, another thing. So yeah, I mean, definitely a good podcast with you, Somdeep, and thank you so much for joining in. I'm sure I have learned a lot during this podcast. So thank you so much for coming in and joining for the podcast.
Thank you. Thank you, Mehul.
Sure. Take care. Bye.